J0313-1806 is a high redshift quasar located about 13 billion light-years from Earth in the constellation of Eridanus. It is best known for being the most distant quasar in the observable universe and having the highest redshift for a quasar, at about 7.64, forming just over 720 million years after the Big Bang. The quasar is the galactic center of its host galaxy, which is likely an elliptical galaxy or an irregular galaxy due to its distance and age. The host galaxy is a starburst galaxy, with an estimated star formation rate of 200 solar masses per year. J0313 is powered by a supermassive black hole, clocking in at a mass of 1.6 billion solar masses. This gives it a diameter of over 60 astronomical units, meaning that it would engulf past the Kuiper belt and then some if placed at the center of the solar system. The black hole is estimated to have an average growth rate of 25 solar masses per year. Upon its discovery, J0313 would be described as the most massive supermassive black hole known, with a redshift greater than 7. The black hole would puzzle astronomers though. Due to its size and distance, it's huge for the time period that it formed in. And to give an example of how massive the black hole truly is, the quasar P17218, currently the farthest known radio-loud quasar, formed almost 840 million years after the Big Bang, and has a mass of merely 290 million solar masses, which is child's play compared to J0313. Multiple theories have been proposed to explain why the quasar is so massive, ranging from population 3 stars being consumed by the black hole to multiple black holes being present in a dense star cluster. The first theory, and probably the most unlikely, is that the first generation of stars present in the universe became food for the black hole. This would be supported by the fact that these stars, also known as population 3 stars, would be made solely out of hydrogen, helium, and potentially lithium, due to the time period. These stars would be very massive, which means more mass for a black hole to feed on. The problem: population 3 stars haven't been proven to exist yet. They're very likely to exist, and have a high probability of lurking around even in nearby galaxies. However, even if they were proven to be real, the amount of mass consumed is unlikely to be enough for the black hole given how soon it formed after the Big Bang. The second theory, which could be probable, is that multiple black holes formed within a dense star cluster, causing mass to accumulate very quickly. The mass of these black holes would likely be of intermediate mass, since black holes at the center of globular clusters are generally larger than stellar mass black holes. The problem with this, though, is much like the first theory. Mass likely wouldn't have been able to grow fast enough that early on in the universe, despite more matter being present. A common problem between these two theories, if it wasn't already obvious, is that it appears mass can't accumulate fast enough. And this is likely due to the fact that the initial mass for the black hole would have to be 10,000 solar masses for it to form in time. However, even for that to work, the black hole would have to begin growing at a minimum of 100 million years after the Big Bang in order for it to reach the mass it's at in enough time. There is a third theory for why this black hole is so large, though, and it appears to be the most accepted theory thus far. It's believed that the black hole likely formed through collapsed cold hydrogen gas, and it's likely that from there, it grew exponentially with time. This object in particular is important for us to study, as it not only gives us a looking glass into the ray ionization epoch, but it also challenged our knowledge on black hole formation at the time of its discovery due to the mass it grew to in the amount of time that it did. As stated earlier, J0313 is redshifted due to the universe's expansion. This means that objects such as galaxies, quasars, and gravitationally lensed stars are moving away from us, with some objects moving faster than others. This is shown in the object's redshift value, and as a result, Objects further away from those in the local universe generally move away from us at faster speeds, and can end up with a distance greater than 13.8 billion light-years, which is the current age of the universe. This is the case with J0313, with it having a redshift of 7.64, as stated earlier in the video. This means the quasar has a helio-radial velocity of about 2,291,000 kilometers per second, or 1,424,000 miles per second, which gives us a co-moving distance of about 30 billion light-years, about 230% farther than its light travel time.